Hello, everyone. We are back with our fourth day of the World Space Week. My name is Shaurya. I'm from SSERD, and I welcome you all on the fourth of the World Space Week program 2020, organized by SSERD. Hope you all are enjoying this Space Week with us by participating in various workshops, keynotes, and competitions organized by our team. After a wonderful session on environmental monitoring through the Earth observation data, Bilasha Purva from Blue Sky Analytics, we have another keynote coming up. So today we have a second interesting keynote on communication and navigational slides by Devleena Bhattacharya, founder and CEO of Numer8. She's an entrepreneur and a data scientist with 15 years of experience across the US, Europe, New Zealand, and India. She loves to build data-driven products, solving real-world problems with data-driven insight. Talking about Numer8 is a big data science company incorporated in April 2018. Numer8 works with businesses, governments, and international agencies like the United Nations, helping in effective decisions on planning, development, cost, and revenue. They use geospatial data for micro decisions affecting governments, businesses. And they have successfully launched two world-class products that are recognized and awarded by international organizations and companies. It was a great honor that you accepted the invitation, ma'am. Can we have you on screen?
Hello, Shreya. I'm hoping you can see me.
Yeah, you are clearly audible and visible. It was a great honor that you accepted the invitation.
Well, thank you so much, and good evening to you. Good evening to everybody here. And well, first of all, congratulations to the entire SSERD team for running such a fantastic program, and not only through the Space Week, but continuously with students across the world. So I personally wanted to, congratulate all of you for running this fantastic mission, and it's a great honor for me to be here as well. It's very different from typical, presentations that I do. So I'm very excited to be here to speaking to all of you about, the topic today. I'm going to quickly share my screen. Let me know if you see my screen.
Yeah. Thank you. It was a pleasure, and I will not take much of your time. The screen is all yours.
Okay, so great. So I see my slide there. So going back to as I said, thank you for the introduction. And so we are a data science company, and we do various kinds of data analysis. We not only analyze space data, but we also analyze a lot of IoT data, various other sensor data, and transactional data. However, space data or satellite data is very vital to us for our products, for our technical capabilities, and for the community that we serve. You earlier spoke about the United Nations World Food Program and how they are supporting us in what we are doing. So we are very mindful of the fact that data is used for the global good. So we build products that has a global outreach. We build products that has application for not only in the urban dwellers, but also for the rural development, for people living in general populations, people spread across the world. So our products typically cater to that. And so we're not really building satellites and launching them, but we are building downstream products that analyze satellite signals, images, and data as a whole for a specific application. So coming back to our current topic of the day, that is satellite communication satellites and navigation satellites. So let me. What you see in front of you is it's an experiment. It was called ECO-1. It was done by NASA in 1960. It was the first attempt of bouncing of communication signals from one point of the Earth to the other. But since then, we have come a long way. We are currently living in a global village where satellite-based communication is used in television, in your phones, in radio, in internet, in military applications, various such intelligent applications. we now have a constellation of satellites roaming above us in various orbits, the low Earth orbit, the middle Earth orbit, the geostationary orbits, the polar orbits, and every one of them has its own specific use. We have reached a space or reached the age where we are currently space as a sector is being commercialized, by which I mean space industry is helping us build downstream application that has tangible values to the customer. It is no longer a bunch of scientists locked up in a laboratory with very difficult mathematical calculations, but all of that has now reached the downstream sector by an user walking around the road using a GPS, or somebody sailing across the earth, or using a flight. So what we see now is space industry, or the satellite images, the satellite data that it produces is currently being used of in the commercial usage. And what you see in picture is that of Apple. I'm sure all of you know, because in coming from SSERD you should be knowing this is something. This is an experiment that was done, experiment communication satellite launched by ISRO in 1981, and it's called the Apple. But what I'm arriving at is that we have come again away from that. What we see now is satellites fitting a pocket with 1,000 times more capacity, computing capacity, and being able to help us communicate across the world, across Earth, land, and air. I once worked in this client called Inmarsat, which is a British satellite telecommunication company, and had ground stations through 13 geostationary. They had ground stations through 13 geostationary telecommunication satellite, and Inmarsat has solutions for both maritime and aviation industry, where they were helping not only the airline, the pilots or the sailors or the operators, passengers across the world to communicate with each other wherever they are. If you're traveling through a remote desert, you can use a satellite phone. So that is what Inmarsat was providing. So such applications are what we see in the communication, apart from using your own television in your from the comforts of your drawing hall. When we talk about navigation, navigation is when where we are telling a user or telling a customer where to go and where not to go, rather. If you're out on an adventure, you do not exactly know where you're headed, and you are lost, which both has happened to me in the past. I have quickly pulled up my mobile at my location, and I've come to know where I am positioned, where I can go. So it might be while driving a car that uses GPS maps and to reaching an unknown part of the country where you have never traveled, or in a airline by airline pilots to know their way. The GPS, as we know, the Global Positioning System, uses 24 US Department Defense satellites to provide precise location data such as aircraft position, track, speed for the pilots. And it uses something like a triangulation system to determine the position of the exact position of the aircraft on Earth. So, and this GPS satellites have something called the atomic clock, which provides extremely accurate time, and the lat and long, and the altitude, and the time all computed and sent to the pilot. A similar kind of architecture is used by ships as well, and I'll speak about more of that when I come to the next section, because we do some work around marine navigation, and especially to the fishing industry. So what we see, and what we have, and what we've also seen as parallelly growing in parallel to the satellite industry or the space industry, is the devices or the transponders that can enable us to access satellite data. They have become easier to hold, and they become easier to purchase. Earlier on, you had this very heavy and expensive transponder systems, but now all of that information can fit into the palm of your hands and wherever you go. And they are being used continuously by this autonomous vehicles or self-driven cars that you keep hearing about, or by a drone that is sent to monitor a certain remote area of a country. All of that uses satellite-based navigation. And one part of it is, of course, surveillance and security. I don't know if been following the news, but if you ISRO a few days back, they said that they are releasing some 10 new satellites in space for navigation to be used by the Indian military by the 2021. And these satellites help us to have and keep an eye in the sky for various terrorist activity, for monitoring our land borders or country borders, for monitoring maritime activities, or any other such of infiltrations. And what is called something called monitoring, surveillance, and control, which we also use in our product. I'll show how we are using it, but that is specifically using satellite navigation to know an exact position of a vessel on a ocean, to know who owns a vessel. It's not only knowing what is it, but who owns it, so that in case we find that vessel or a ship or a fishing boat engaging in wrongful activity, we can punish the owners of it, and we can track it across the routes they are taking across the seas, and we can see how long it was stranded in a certain area. So all of the information can be deduced, layered over with various other satellite data, like satellite images of the ocean images, and with that can draw very intelligent analysis of what your ports and harbors are looking like. So MSC is not only used for by coastal police or by your surveillance industry, but also it is a very beneficial thing to track and control the number of vessels out in the sea. So that you must have heard about SDGs. I'll touch on that later, but it is where you're saying that you are being able to control the amount of activity that is going out in the ocean, so that that the oceans are not getting polluted, the oceans are not getting overfished, the oceans are not being used for illegal activities. All of that kind of comes under the MSC, or monitoring, surveillance, and control, that is enabled by our satellite-based navigation. One other thing that we use, and we have built an application called Curiosity around it, is called emergency response, where suppose a certain flood, a coastal event has happened, or a landslide has happened, or any other kind of earthquake has happened. So all of that, what is the geophysical changes of that in the on the Earth's surface? So satellite helps you to take on large broad area of the earth and analyze what has happened in the last few hours, who all is impacted, which area has been mostly impacted. So all of that, and then helping search and rescue missions to reach to that place and offer help, is what satellite based communication, navigation, satellite based image analysis helps us. You have gone through last few forums addresses how to use earth observation data, so all of that can be packaged together and used in emergency response scenarios. I was talking about SDGs earlier. The reason I was talking about SDGs, or Sustainable Development Goals, these were developed by the United Nations, and these are 17 goals that helps us make this that helps us do a lot of things. A very small sentence. It helps us build a better world, and build a better world for everybody involved. I've encircled the areas where we believe satellite is helping us actively. The first one that you see is zero hunger, and you might be wondering, well, how does satellite help in zero hunger? But we in fact our product OFISH and Numer8 is helping us build applications that is preventing a certain fisherman going hungry to bed. So we are being able to use satellite data or space images to build products that is useful for a fisherman to earn his income on a day-to-day basis. And if you ask fishermen, why fishermen? Because 70% of the fishermen population across the earth, across the world, is living under the poverty line. So we are being able to help them generate some means of income, which is increasing net income, and we are helping the UN to curb hunger. OFISH as a product was selected by the United Nations, and it was selected particularly for this application, where we are being able to help a marginalized community with the help of space data. Quality education. As of today, I'm reaching out to you through internet, but again, quality education for reaching into various remote part of the world is you use satellite-based communication, that you can extend knowledge is not you're not geographically constrained by it. You can spread it far and wide. Clean water sanitation, where you can monitor various such world resources, earth resources, and analyze the water, analyze the quality of water, analyze the pollution level of the water, analyze the algae bloom of the water, and apply solutions that are typically can help improve the water qualities and help to improve the health qualities of people surviving on it. So that can be done through satellite imaging. Your clean energy, where you're building various such clean energy products before in across the world, and where you will need to implement it, where the most risk based risk to implant a clean energy product is where satellite imaging can help you. And various other, I think, keep talking about it. SDGs are something that are very close to us, close to our heart, close to our company. And I currently your satellite based navigation communication helps us in delivering this goal. Coming to what we do, I told that we work with the fishing community. So what we provide them is a very simple to use application. A fisherman can open the application in the beginning of his journey, and he gets to see what is out there. Should I really go out fishing? Is the weather suitable for me? Are there what are the fishing zones like? What are fishing zones? Fishing zones are where we see there is a probability of fish occurring. We do this analysis based out of various data that we derive from space images. So all of that is helping us guide a fisherman to be safe on the seas. Why do they need such guidance? Because climate as a whole has changed over the last few years. Climate change has heated up oceans. Your climate change has changed the cyclical pattern of fishing. So for them to be able to navigate through such unknown territories, where you have frequent coastal flooding happening, if you have frequent tropical cyclones happening, for them to know, or for them to have a very easy to use application through which they can charter their way through choppy waters, is what what we're helping them with. And all of that is available to them in a simple mobile phone. We also tell them about sea currents, about tidal waves, or any kind of what was the height of wave, was the wind direction, what is the wind speed, so they know exactly where to go, how long they are going, what is the indicative fuel cost, and all of that is derived from insights, or derived from data that we are getting from space-based satellites. What we also provide them is something called the ocean floor terrain, or we call bathymetry. What bathymetry helps a fisherman to know is, okay, how deep the ocean is, where we are, where I am currently. I'm in the port, I want to go to this part of the sea. What is the depth of the ocean floor? How does it help them? Because they get to know what kind of nets do they carry. And depending on the ocean floor depth, there are also certain fish that they know, okay, which fish is at what level of the ocean. So they also get to know in advance what fish they might find there. So all of that information is given to them on a phone. And we are being able to also, as I said, navigation helps us track routes of the ships. So we are also being able to track where they're going, how long they're spending, and all of this is helping the government or the military or the coastal police or the intelligence bureau to understand what is the vessel activity like in a certain part of the ocean. Is there any kind of terrorist infiltration? Is there any kind of illegal activity that is happening? Should I question a vessel about the data? So all of this is being held by information that we are drawing from satellites. So all in all, we are not only helping, not only telling them where to go, but we're also telling them or helping them to come back to their home safely. What we like the transponders, what I told earlier about this mobile health devices, so they can communicate with the coastal police. They can communicate with their fellow fishermen if they're in trouble. So they can talk about where they are, and such a rescue team can go get them and bring them back safely. We have reached the stage where there's a two-way communication, and you can also exchange texts over such navigational devices, where you are at any given point in time can reach out for rescue, can reach out for help. Doesn't matter where in the ocean you are. So overall, I wanted to say I started with where communications we started back in the day, but as of today, we have reached a level where these kind of satellites are helping us save millions of lives across the world, helping us build a better world, helping us reach out to the marginal section of society apart from just the urban dwellers, and of course build a better world. That's all from me. I'm happy to take any questions. I see there are a lot of questions already. Um, should I start answering them?
Yeah, thank you so much, ma'am, for that wonderful session. It was great. So we have a couple of questions from our live chat. We can take one by one. The first one is, can we monitor submarines using satellite?
Yeah, good question. So there are various, yeah, we can. There are, but of course to a certain depth, and there are various such, and it will, and you need a lot of image processing to be, to help you do that. And we have seen such applications. But submarines, remember, submarine is a, is a military, it belongs to the military or navy. So they are also careful about not giving out their location. So they also have advanced solutions to be able to not detect them. So, but to a certain level, you can definitely detect uh, fish or as big as an object like submarines.
Great. And we have another. Can we monitor the whole Earth by a single satellite?
Not typically. That's why you need a constellation of satellites where it is spread apart. So even speaking about and it depends. If you need to monitor a certain place, how frequently do you want to monitor a certain place? Satellites have various passes, right? So if you're okay to monitor a certain place within in a 3 to 5 days time, then maybe one satellite is enough. But if you want to monitor a certain place, or say even India, or say even say Bombay, for 24/7, then you'll need a constellation of satellites. So they go on in passes, but you should have the continuous way of monitoring a certain the place of your choice. So that's where you have multiple satellites in the space, everybody monitoring a certain area, and you get those images from across different satellites given to you at different points in time.
Great. Uh, let's take another one. Yeah. What happens when a mission communication with satellite is lost? Like, for what happens when the communication is lost by the satellite? What we can?
Well, if you're talking about satellite not functioning, I'm not the right person to answer that. I'm not, rocket scientist. But when you talk about downstream systems like us, suppose I am building my system based on data got from certain satellites, but when we build it, we make sure that we have a default behavior. So as I said, certain place in the Earth is monitored by many satellites. So I'm not dependent on a certain satellite not functioning at one point of time. We have our what we are providing to the user should always be up and available, right? Should always be available 24/7. So we make sure that when that this data is sent to us by multiple satellites. So even if one satellite stops sending us data, the other satellite can is giving us data. So our application is built that way. So the failover or such exception conditions is handled within the downstream application. But if your point is about what happens if that stops communicating, I think that's best asked to somebody who knows how to build satellites.
Yeah. So this is interesting actually. The next one. What happened with the Chandrayaan 2 connection?
Yeah, I don't know about that. Sorry, I'm not the right person to answer it. But you
Yeah.
might definitely, if you need more details on that, you should ask somebody who builds the satellite and who is actively, building, in the hardware. I unfortunately come from the software industry, so I would be not be able to answer that question to be with the full details that you need.
Yeah. Great. So yeah, we can take this. Can we use this system to find oil mines, natural gas, and
Yeah,
under the ocean?
definitely. There are Sure, there are various applications of using satellite image for finding oil mines, for finding natural gas, and not only finding them, for being able to monitor them over a larger period of time. You have Earth observation satellites that help us assess soil quality as well. Every mineral has their own you can basically understand from the reflected radiance what mineral it is, and it is true for both land based and water based. So all of that can be done with Earth observation, marine observation satellites, or image analysis.
Okay. You
I think
talked
there was a
about
question
the.
about
Mhm.
how to find fishing zones with satellites by Aviraj Power.
Yeah, yeah, yeah,
Okay. Okay, so this is what we do. So I can speak at length about it, but I'll keep it short.
yeah.
So again, this is where we analyze the color of water, or seen by a satellite. So okay, a certain color tells us, okay, how much chlorophyll is there in the water. A certain color tells us what is the SST, or the sea surface temperature of the water, what is the sea surface height of a certain place. And all of that, there are various 9 different parameters that we analyze, and we say, okay, this is the right zone for fishing. So because fishing zone, or fish breeding zone, is actually the correct way of mentioning it. Fish breeding zone will only happen when you have the fish food there. Fish will come to a place, and if they have food to eat. And how do you measure that? You measure with the amount of chlorophyll presence in the water. If the temperature is right enough, it is not too hot or too cold. So all of that can be measured by the ocean observation image analysis, and we do that, and then we say, okay, this is the place where the potential fishing zones are.
Great. Uh, Earlier, you talked about the Fisherman app in your presentation. So, can you tell us what is the name of that software that was
Yeah,
being
sure.
used?
Look it up. It is there in the Play Store. It's called O Fish, single word, and you'll find there are 2 apps. One that helps us uses most of this weather data, satellite data, bathymetry details. You can download it and use it. It will show you fishing zones nearby you. If you want to go out fishing, you can use that for your use. And also we have other data that helps fishermen to sell the fish. So we are actually since we are a data science company, we are what we are currently building for the fishing community is giving them an end-to-end and a platform for not only finding fish but selling fish as well. And this is where I last spoke of the MSC. What does MSC does? MSC is monitoring, surveillance, and control, where you get to know where your fish has come from. Why it is important? Because if you know where your fish has come from, then you'll be able to track and trace every fish that is getting sold in the shops, and then you can actually help control the overfishing or the illegal fishing that is been happening. So if a fisherman is using unsustainable means of fishing, if a fisherman is using bad nets or in the small mesh sizes, all of this can be tracked and controlled. So we are using a number of data points to be enabling this entire supply chain. It starts with satellite, it starts with space-based images, but it also goes across the supply chain to the end consumer. And but
Okay.
yeah, please definitely look it up. It's called Ofish.
Yeah. So, we can take our last question for the day. How close can a satellite can be to a Earth?
How close can a satellite be on Earth, and does it affect the resolution of the pics it takes? I think the closest is the International Space Stations. That's what we. But I don't know if there is a limit of how close it can be to Earth. But I believe after a certain, because otherwise the Earth gravitation is going to pull it down. So there is a certain level. Maybe you can find that answer and tell me. I don't know the meters, but there's definitely some distance that we need to ensure that the gravity does not pull it down to the Earth often. What you see, there is one question which says, what will happen to a junk satellite which is lost and is orbiting the Earth? This is exactly
Yeah.
what happens when a satellite is lost his purpose, has run out of his time. It starts falling from space, gets pulled into the Earth, and gets burnt while it enters the Earth. So you have many such satellites roaming freely across the, if you look up, there are websites that will tell you how many dozens of satellites are there on the currently floating in space. And one of when they lose its purpose, it just falls through the atmosphere and gets burnt up.
Great. That was a very wonderful session by you. Thanks for sharing that wonderful knowledge. And thank you for accepting our invitation from your valuable schedule. And it was a great honor. And I thank you on the behalf of the whole SSERD team uh, for joining us in the celebration of the World Space Week. Thank you, ma'am, once again.
Thank you very much, Shaurya. Thank you to entire SSERD team, and wish you all the best.
Yeah, thank you.
Thank you.
Yeah, so that was it for the fourth day of World Space Week program. We still have so many competitions running now. You can participate in any of them, and don't forget to check our website www.sserd.org/WSW2020. And we still have 3 days left in the World Space Week. So you are not late if you haven't registered. Do register for the World Space Week. And yeah, take care. Bye bye.